Hello Matrix and welcome again. Today we are going to be doing cubic functions, and I want to look at cubic functions when they just have one root. So first of all, I'm going to show you briefly what a normal cubic function with three roots would look like. And in the last video, we actually saw an example where we had a cubic function with two roots. And then finally, we'll look at the option with third root, just one root. And then we will do this past paper question from 2019. And this took a little bit of understanding more than just kind of drawing the graph. So we'll get to question 9 now. But first of all, let's just look at a cubic function. So usually it kind of will look like that. And there'll be three roots, right? 1, 2, and 3 that I've done in green. Now, what we had last time was an example where the second and third root actually touched on the x-axis. So we ended up with just two roots. And we saw this one, when you factorized, one of the roots became a perfect square, giving you the same root. So this one had two roots. Now, what could also happen is we could have a situation where we get just one root. And a cubic graph doesn't always necessarily have to have this shape. It can also have a shape which would also give one root. And I'm going to do that there, where you get a shape like this. Okay, and so we would just end up with one root. Now, this question here, question 9, is one such example where you have one root. But first of all, I'm going to do the question, and then we'll see why. Okay, so if you were to, okay, so this is the function f of x equals 3x cubed. So again, it's an x cubed, so it is a cubic function. So what I want to do briefly is just draw this before we even get to the question. Well, what happens when I make x equal to 0? Well, I get 3 times 0 cubed, which is just 0. So I know that this equation actually passes through the origin. Now, let's put in some values. Say that I have 3 times 1 cubed. Well, that would just be 3. If I made 3 times 2 cubed, it would be 3 times 8, which is 24. If it was 3 cubed, it would be 27 times 3 is 81. So I notice that it's getting very big as x value gets bigger. And so, but if I go the other way, negative 1 cubed is negative 1 times 3, which is negative 3. Negative 2 cubed is negative 8. And so it actually goes this way on the other side. And so because my a is positive, it looks similar to when a is positive. This would be an example here where a is positive, the one I've just done here where a is positive, because as a gets bigger, the y gets bigger too, and as if a is negative, then when x gets bigger, the y gets bigger. And when x gets smaller, in other words, towards the negatives, we get negative times negative times negative, which is still negative. So as x tends towards negative infinity, we get a very small number. And so this is a is positive. I'm going over this again for those of you who didn't see the other videos. Now, if a is negative, it would be, I'm going to draw that now with in pink. That would be where a is negative. And so if this was negative 3x cubed, it would look like this. Okay, but it doesn't. But it would be negative 3x cubed would be this one. So the blue is the f of x equals 3x cubed. Okay, so just drawing that to improve our understanding, but let's get stuck into the question. Okay, so we see that in this question we have one root. So it's possible for an x cubed graph to have one root. Now, they said solve for f of x equals the derivative of x? Well, f of x. Well, the derivative of f of x is equal to 3 times 3. Well, let's just write f of x first. 3x cubed, so that we just remember how to define the derivative. We say the exponent times the number in front, so 3 times 3 is 9. And then we take 1 off the exponent to become 2. And now we have to solve for f of x equals f dash of x. So we say, well, f of x is 3x cubed, f dash of x is 9x squared. And of course, everything goes to one side now. Minus 9x squared equals 0. I can take out 3x squared, and I'm left with 1 minus 3. Sorry, x minus 3. For 0, and my solutions are 3x squared equals 0, or x minus 3 equals 0, so I get x equals 0, or x minus 3 equals 0, and so then I get x equals 3. For which of the graphs will 0 be a stationary point? Okay, so what I want to do is I just want to actually draw in the f dash of x. So I'm going to just underline this in yellow, f dash of x. Well, if I was to draw this as a parabola, it's a smiley face parabola that goes like this in the graph, because it's always positive. It's because when x is negative, negative 1 times negative 1 is 2. So this is a smiley face graph, parabola. And so, yes, I get a stationary point for f of x. And so for f dash of x, I beg your pardon. So this was 9.1. I'm going to put 9.2 on the side here in yellow. It's going to be f dash of x. Let's look at the second derivative, f dash of x, in number 2. So we're going to do that in green. So f double dash of x is equal to the derivative of f of x, which is 9x squared, so it's going to be 2 times 9 is 18. I take 1 off the exponent, so I get 18x. Well, this is a straight line graph with a very big gradient of 18. So this one is going to look like that in green. Okay, so the yellow is the derivative, the green is the second derivative, f double dash of x, and blue is the cubic function. Okay, so hopefully we're getting somewhere. Now, 9.2 so this was 9.2.1 that we just did with the f dash of x. We can see that the green one does not have a stationary point. And, we also need to look at the blue one. Well, the blue one has a stationary point, because what happens is it changes. If we look at f double dash of x, that tells us the point of inflection, which is where it changes from concave up to concave down. I'm going to do that in a sort of a, we can see it's concave down from negative infinity to 0, and then concave up, the blue bit over here. So it's concave down till it gets to 0. So we have a stationary point for the blue graph, the f of x. So I'm going to put that in blue just so that we can follow what's going on. So f of x has a stationary point where it changes, the slope changes. And now, explain the difference between the stationary points referred to in question 9.2.1. Well, the parabola has a stationary point, so 9.2.1, the parabola, let's do that in yellow because we're going to refer now to the f dash of x. f dash of x stationary point is a local, in this case, minimum. Okay, or the stationary point is a turning point, we could also say. Whereas the stationary point for the blue graph is simply just a point of inflection. So we can say for f of x, it's a point of inflection. So it's not a local max or minimum. So it's not a max. Whereas the yellow was a max. Not. Okay, this was for 2 marks. So we've got enough there for 2 marks, possibly even a few more marks if there were more. But I think that they're looking for something like this. The memo for this is not out yet, but it should be out hopefully, I don't know, in 2020. Okay, what is 2020? So the end of 2020. Okay, 9.3 says determine the vertical distance between f dash of x and f double dash. So when we find the distance between 2 graphs, all we do is we take the functions of the graphs and we just subtract them from each other. So that's what I'm going to do here. So f double dash of x, second derivative was 9x squared. We got that. And we're going to subtract the second derivative, which is our f, which is our 18x. So we're going to subtract 18x. Let's do that in green. Now, for those of you who do AP Maths, if you subtract the graph that's higher from the graph that's the lower, so in other words, say these were, I'll draw the, let's zoom in on these graphs. So say we had the parabola like that and the straight line like that. If I subtract the graphs at the point that I'm going to draw in purple, I'm doing yellow minus green. And do you see the green is higher than yellow? So I would actually get a negative value. But of course, the length is not negative, because it's just that the value we would get would be negative. But if I did the yellow over here, let's do it in, I'll do it in blue. Yellow minus green, well, there we do get a positive value. So what I want to do is I want to put in this sign, which just means the absolute value, meaning that if it's, whether it's negative or positive, I'm going to just give the value a positive. So in other words, if this answer comes out as -3, I'm going to make it +3. If it comes out as +3, it just stays +3. One thing to note, this 18x has a very steep function. And so it's very likely that this graph 18x is actually going to be higher. So we probably are going to get a negative value. But let's see what we get. Well, the distance, let's just say the distance is equal to that, right? F of x minus, sorry, this is f double dash of x, and this is f of x. And what I want to do is I want to substitute in distance of, they ask it at x equals 1. So I'm just going to say d of, so this is distance function, and I'm just going to say d of 1. Because it's a distance where x is 1. And I'm going to say 1 squared minus 18 times 1. Oh, and so I do get -9. It's the absolute value of -9, which is 9. If you haven't done AP Maths, it's fine. Just remember, if you get a negative value, just change it to a positive, because your units are, the length of is going to be a positive length, even if you do get a negative value. So if you didn't understand what I was talking about there with absolute functions, not a problem. Just remember to say positive when you're getting the length of a distance between 2 graphs. Okay. Now it says for which values, okay, so this was 9.3. Let's see if we have a bit of space here to do 9.4. For which values of f of x is f of x minus f dash of x 0. less than 0. Okay, so what I need to do here is, once again, I can simply just put in the functions. Okay, so I'm going to do that now. So the function of f of x, right, is 3x cubed. So let's put that, I put that in blue. So I'm going to keep the theme of using the colors. I should have put this in, I'm going to put that in. This is 18 times 1, that was green. So we're going to say 3 of x. Now, obviously, in the exam, you're not going to do all these colors. The reason I'm doing this is just so that we can see which graphs we're talking about. So the f of x is in blue. The f of f double dash, in other words, the derivative of the blue one, is 9x squared. And where it's greater than 0. So what I'm going to do is I'm going to get critical values. So all of the values. So critical values. So we're going to do it up here. Critical values. We make it equal to 0. So these are the values where the graphs will be equal, will be the critical values. And then either side of those will be greater than or equal to. Greater than or less than. Okay, so I'm going to take out a 3x squared. And I get, oh wait, I already did f of x equals, I'd got the critical values in 9.1. Critical values from 9.1, which was where they're equal to each other, is, where was it? X equals 0 or x equals 3. Okay. So that was over here in 9.1. So now what we do is we get a number line. And we put in our 0 and our 3. Now what we can do is we can now test values on either side. So say I put 0 in here. 3 times 0 cubed minus 9 times 0 squared is 0. And of course that we're expecting to get 0 because that's a critical value. And if I put in 3 into this equation here, I'm also getting it 0. So, but now we're not interested in that. We're interested in where it's negative. So if it was, say, negative 100, well, we can just put it into our calculator. But I'm not going to. Say x was negative 100. Well, negative 100 cubed is just negative 1,000,000. And so that's going to be just, it's definitely going to be negative where it's below 0. Now, what I do for the next one is substitute a value in between 0 and 3. So I'm going to put in 1. Well, 3 times 1 is just 3, and then minus 9 times 1, so it'll be negative again. And then if I make it positive 3, well, if I put in 1,000,000 for x cubed, it's going to be just a massive number, right? It's going to be negative 1,000,000 times, it's going to be 1,000,000 times 1,000,000 times 1,000,000. So that's definitely going to be positive. Now, of course, you can just put in values into your calculator for this to check. And so where is it? And we're wanting it where it's negative. So I'm going to tick where it's negative because it's less than 0. So it's over here and over here, but not over here. So in red. So basically what I'm saying is that x is going to be less than 0, but it can't be, less than 3. Because it's the 3 there. But it can't be equal to 0. Because remember, it's a greater than only sign. Less than only sign. So it can't be equal to. So we also must say that x cannot equal 0. Okay, so that's the answer for 9.4. Okay, so that's cubic graphs. We've done one in the last video where we looked at a perfect square, which resulted in you getting 2 roots. In the videos before that, I'm sure we looked at 3 roots. And now we've looked at one which had just 1 root and also just a very different way of asking the question. So hopefully you understood all this. Thanks for watching. As I say, well done for keeping on with your matric and getting to calculus, and just keep on going, because we're going to be doing optimization next, and then after that financial maths, and then we're done with paper 1, and then I'm going to do some lessons for paper 2. So subscribe, because you definitely want to get notifications of when I do these lessons. The more you practice, the more videos you watch, the better results you're going to get. That is statistically going to happen. So I will, if you found this video helpful, find the subscribe button down below, click it, because you will get notifications, and like, subscribe, and all that good stuff. I will see you next time.